Hello everybody. It's so great that I can talk today about amazing glomeruli in high-resolution microscopy. My name is Nicole Endlich. I'm the CEO of NIPOCA and the Managing Director of the Institute of Anatomy and Cell Biology at the University of Medicine here in Greifswald, Germany. As you know, podocyte, a highly specialized cell type, covers the outer aspects of the capillaries in the filtration unit, the glomerulus. As you can see here in this scanning electron microscope, the tiny podocyte foot processes interdigitate with the neighboring tiny foot processes, and in between a filtration slit is performed. However, the limitation of electron microscopy is that it is a sophisticated and time-consuming technology. You have only 1 to 3 glomeruli with a thickness of 50 to 90 nanometer. You need a specific fixation and embedding. And the most important part, you have only a subjective analysis and therefore with a limited reproducibility. Precision medicine of the future needs, however, precision in the analysis, a quantification of changes, a reproducibility, and representativeness. Now there is a change in the world. There is a so-called super resolution microscope. We use SIM. SIM stands for Structured Illumination Microscope. It's a new light microscopic technology that overcomes the physical limitations in the past and accelerating and improving research, drug discovery, and have an improvement of diagnosis. You have now an optical resolution of up to 100 nanometer, making it possible, as you can see here, this is a wide field image, and if we convert this into a super resolution image, you can see the green lines, which is a filtration slit, between the interdigitating foot processes here in black. You can clearly resolve it. Now we have developed a specific procedure. It's called PEMP. PEMP stands for Podocyte Exact Morphology Measurement Procedure. And what we are doing is we take standard histological formalin fixed and paraffin embedded sections. We make a double staining with an antibody against the filtration slit. Here, for example, an antibody against nephrin, as well as an antibody for the podocyte foot processes such as synoptopodin. Then we make a whole slide image and we make a clone selection. You see it here, it's a cross-section of an animal kidney, and also colored glomeruli are shown here. Then we make a so-called image acquisition in 3D, going through the whole sample and take also information of the podocyte foot process morphology. The most important step is the quantification of the filtration slit. So meaning we measure the filtration slit length here, divide this through the area where the podocyte foot processes are attached to the glomerular basement membrane, and this is the so-called FSD, filtration slit density. Here in this example it's 4.1 micrometer per square micrometer. What does it mean, an FSD measurement? So FSD tells you something about whether your podocyte morphology is healthy or effaced. So these two cartoons should illustrate this. You have interdigitating foot processes. In between you have the filtration slit in green. Here you have tiny foot processes, therefore the filtration slit is very long and the FSD is high. In the second image here, you see a broadening of the podocyte foot processes and therefore a reduction of the filtration slit, meaning you have a low FSD value. Here you see an example of a human biopsy. You see the double staining of podocin and synaptopodin. Here also glomeruli are visible. And now if you take one image of one glomerulus, you see it here in green. You have the slit membrane protein podocin. And for the foot processes synaptopodin, we can now zoom in at any region of interest. You see here something has changed. You have a lot of podocyte foot processes. However, you have no filtration slit in between. And if we further zoom in, you see side by side nicely formed foot processes. Here is very tiny foot processes in contrast to this situation here where you have a broadening. Another example, you have one whole glomerulus and we zoom in into a region. One shows you here in this upper part nicely and perfectly formed foot processes, in contrast to the situation on the left-hand side where you see that you have lost filtration slits and you have a broadening of foot processes. We have had the luck to be included in a pilot study in a cooperation with Evotech. So we got 69 biopsies in a blinded way, and after the bioinformatic analysis, it was visible that the FSD also tells you something about the glomerulopathies you are looking for. So here in this graph, you can see each line is one patient and each dot is one measured glomerulus. And now you see minimal change, for example. This is the FSD value, high to remember it, is healthy, and one is effaced. So what you see is that the FSD is very similar in all glomeruli in minimal change disease, which was also expected. In contrast to IgA nephropathy, where you can see FSD values which are really nearly healthy and very low, meaning there is an effacement of the podocyte foot processes. We also realized that the PEMP is a milestone for clinical studies. But this is not the whole story. You can also include biomarkers to identify several changes in biomarker expression. You know probably how difficult it is in a high resolution analysis with the electron microscope to identify specific location of proteins of interest, as you can see it here for podocin. This is easier if you do it in a double, triple, or more staining, multiplex staining with a super resolution microscope. Cells. Yeah, this technology we have now used, I think, in 23 really high-ranked publication, and it's working very well. As a summary, I would like to tell you here with the first time you have comparable values on glomerular level. You can use a high number of glomeruli. Normally we take in animals 20, but you can also take 100. It's unbiased and reproducible. You can use it for all glomerulopathies, and you have a high degree of automatization and high throughput. Yeah, the next generation analysis in nephrology will be done by super resolution microscopy, which accelerate drug development, personalized diagnosis and therapy, and the optimization of transplantation. And the first department of pathology, which will include in the diagnosis this PEMP analysis, is a UTMB in Galveston, Texas. And we are really very happy about this. Yeah, now I'm at the end of the story. I hope I could convince you that it's really a very helpful and quick tool. And if you have further questions, please, you see my email address, contact me. And yeah, thank you very much for your attention and goodbye.